In this problem, I'm going to be talking about in this video, I'm going to be talking about problem 6.24, which is number 8 on the chapter 6B homework, another one that a lot of people asked a lot about, largely because there's a lot of algebra in it. So the question says, consider two objects, A and B, of inertias MA and MB, with MB as much bigger than MA. That sign with two greater thans means much bigger than. And the two are moving at constant velocities with VA not equal to VB. So the velocities are not equal to each other. And let V be the velocity of the zero momentum frame. And then ask some algebraic kinds of questions about the differences between the velocity of the zero momentum frame and the objects. So let's draw this. We got two objects, A and B, with inertias MA and MB, and MB is bigger than MA. Okay, so let's draw much bigger object, much smaller object. So they've got their inertias MA and MB, and whatever those values are, this one's much larger. And then there's VA and VB, and they're not equal to each other. So that means they're actually going to hit. If they were equal to each other, that means they're going in the same direction at the same speed. They'll never actually hit each other. So then the total inertia of the system is the sum of those two, MA plus MB. And then the momentums are MA, VA, MB, VB. And then the sum is, add them up, MA, VA plus MB, VB. That's actually as much of the table as I need to be able to figure out what they're asking for in this question. I don't really need to write out what the kinetic energy and the relative speeds are going to be. I'm going to do it though. I think I understand one of the issues with this sort of problem is that we're really not used to doing this much algebra with no numbers at all. And like, what does it mean that one of the inertias is much larger than the other one with all of these symbols? And maybe you just you feel like you don't know how to start this. You just sort of like trust the symbols, move the symbols around in the way that you know how to do with your experience from algebra and other math classes, and it'll work out. And you can use the same physical reasoning. You don't need the numbers. But I know that's hard because that's a little bit of a new way of thinking. So the kinetic energy is 1/2 times the mass of A times the velocity of A squared, and the kinetic energy of B is 1/2 times the inertia of B times the velocity of B squared. And then you add them all up to get the kinetic energy, 1/2 MA VA squared plus 1/2 MB VB squared. Let me make this bigger. So that's easier to read. And then the relative speed is the absolute value of VA minus VB. I mean, yeah, it's all symbols and we haven't simplified anything in any way, but that is what it would be. And if there were numbers there, you would know how to plug those in and get those results. Okay, so the question is asking about the zero momentum reference frame. So my daughter just ran in here in the middle of that, and I'm not going to edit it out, but I did stop it while I dealt with her question. Okay, so the question is asking about the zero momentum reference frame. What is the zero momentum reference frame? That is the reference frame in which the center of mass isn't moving. So the velocity of that reference frame is the same as the velocity of the center of mass. So what they're asking for here, this symbol that they're representing with V, is the velocity of the center of mass. Okay, so the V they want is the same thing as the velocity of the center of mass. Okay, cool. What is the velocity of the center of mass? Well, the velocity of the center of mass, we've figured out some shortcuts for that, is the total momentum of the system divided by the total inertia. So this V is total momentum, P total, divided by M total, which is MAVA plus MBVB divided by MA plus MB. That's what V is. Okay, so yeah, again, kind of an ugly algebraic expression that's not simplifiable because everything in there is an unknown and they're all different from each other. But that's what it is. Okay, next, it's asking us this weird sort of question that I know we're not used to. What's the difference between that and VA? Okay, well, the difference between that and VA is that minus VA. So V minus VA is equal to that thing, MAVA plus MBVB over MA plus MB minus VA. Okay, that doesn't look like any of the things that are in the options here. So we're going to have to do a little bit of algebraic moving things around in order to make it look like that so we can see which one it is. That's all we're doing. Taking that expression minus VA, and then we're going to algebra it until it looks like one of those. Okay, let's see if we can figure out what that would be. So in order to get a hint of what I need to do, I notice that all four of these are one fraction. So there's one term in a sense. So I can get this to look like that by making everything have the same denominator. It's all MA plus MB. Okay, so I need to combine the fractions by turning this one into one that has MA plus MB as its denominator. Okay, so that means I need to multiply the top and bottom of this by MA plus MB. So that's, let me go in red, minus VA times MA plus MB over MA plus MB. And then the other term is this whole thing, MAVA plus MBVB over MA plus MB. I'm running out of room here already. Okay, so let me move up there. And so now I've got the same denominator, so I can put it all into one fraction, and then I'm going to have to distribute that VA and then combine like terms. So we've got MAVA plus MBVB minus MAVA minus MBVA. Okay, divided by MA plus MB. Now I'm going to combine like terms. And notice that MAVA and the minus MAVA cancel each other out. Okay. And then I've got two different terms that have MB in them. They both have MB. So I'm going to factor that MB to make it look like the things in the options they've given me. All of them have an MA or an MB that's factored out of something. Okay. So factor out the MB. MB times VB minus VA over MA plus MB. That's it. So now let's look at the options that are provided. MB on the top, those are the bottom two, and it's VB minus VA. It's the last one. Okay, there's not, in some sense, a lot of insight there. Like, I don't know how to look at that formula and know what to make of it. I just know that it does tell me the difference between those two velocities. What's the importance of the difference between two velocities? That tells you like how much faster something is moving ahead of something else. So this is a way of figuring out how much quicker the center of mass is than that object, or how much slower, and even which direction they're going, because it'll tell me something about the signs of it. Okay. The other part B, same kind of thing. You've got V minus VB this time. And so I think things are going to kind of work out in the same way with the B's and A's kind of flipped. So I'm not going to go through all of this one. I'm actually going to kind of guess that it's going to end up being this one, because the B and the A get flipped, and the B and the A get flipped in there. And there you go. You should do the algebra to work that out. All right, and then part C, is the velocity of the zero momentum reference frame closer to VA or to VB? This one, I think there is some physical insight in. So the velocity of the zero momentum reference frame is the same as the velocity of the center of mass. The center of mass velocity is going to kind of be weighted closer to the heavier object, isn't it? Because it's the heavier object that determines more what the center of mass is doing, because it has a bigger impact on the center of mass. Like if your system is the Earth and a satellite or something like that, the center of mass basically completely ignores the satellite, because the satellite has really tiny mass compared, or inertia compared to that of the Earth. So it's the velocity of the Earth that's going to matter in figuring out what the center of mass of that whole system is doing. The satellite's not going to change that center of mass velocity or position or whatever very much at all. So it's going to be closer to the velocity of the heavier object. Which one's the heavier one? B. That's what that MA much greater than, I'm sorry, MB much greater than MA means. So it's going to be closer to VB. And there we go. So think about that. In physics, there's a lot of times where that kind of, there's some reasoning about, well, what happens if one of them is much bigger than the other? It's kind of like when you're in calculus, when you're thinking about limits. What's going to happen when this number becomes really close to zero, or becomes really close to, or it approaches infinity or something like that? What's going to happen to the function? Well, saying one of the inertias is much bigger than the other is like saying, well, what happens if we push it towards one of these limits? And then thinking about the results. Okay, that's it for that problem.